I don't. Trying to have a good time in the evenings. Meet me outside at the little event. Maybe we can sneak into the VIP tent. Could you keep a secret? Cause it all depends on how you're walking, how you talk. Ignore the cards. Legends really need no business cards.
Bismillahirrahmanirrahim. Dear students, how are you all? Today our lecture is about hydrogen spectrum, which is basically related to your revision topics. चलिए हम इसे देख लेते हैं. First of all, white light, which is made up of all the colors of the visible spectra, and in the light it is not white. By heating a gas or with electricity you can get it into gives different color. It's a general observation which is indicated in this slide, that whenever light is passed through a prism, it has something different. It means its color spread out, scattered. In this sense you can say that these are scattered. This is white light and hydrogen gas, and they have different continuous spectra, emission spectrum and absorption spectrum. These three type of spectra from white light, hydrogen gas, prism and the simple one. What is the atomic spectrum? You can see that the fingerprint of an atom. Here's a hydrogen emission, hydrogen absorption, carbon emission, and similarly other gases, oxygen emission, oxygen absorption. When absorption and emission, these two are the different terms. Each element gives off its own characteristic colors and can be used to identify the atoms. And what is this behavior? In this light atomic spectrum, fingerprint of an atom, which is called the line emission spectrum, and the light is emitted given off, which is basically emission. Emission is represented as the line emission spectra, hydrogen, neon, and the iron, all where these are emitted. Line emission, here is line, which is indicated it is spectra, and emitted light gives off. You can see here in these three spectrum the difference. What is the hydrogen spectra? Hydrogen spectral lines basically you can calculate from the Bohr calculation energy, frequency, and the wave number of the spectral emission lines, and frequency related formula from their energy levels, N1 and N2. N1 and N2 in this equation basically is the shells, number of shells, N1 and N2, and the wave number of the different spectral lines can be calculated, which is basically corresponding to the values of N1 and N2. What is the Bohr explanation for the hydrogen spectrum? इन बोहर का क्या इसके बारे में एक्सप्लेनेशन थी कि जो इसकी बेसिकली हाइड्रोजन गैस जो पास थ्रू होती है डिस्चार्ज ट्यूब में एट लो प्रेशर, मॉलिक्यूल ऑफ हाइड्रोजन ब्रेक डाउन होते हैं इनटू एटम्स, देन हाइड्रोजन गैस इलेक्ट्रिकल डिस्चार्ज एंड द लो प्रेशर इन कंडीशंस के थ्रू टू हाइड्रोजन एटम्स में स्प्लिट अप हो जाते हैं, ठीक है. And these atoms absorb energy from the electric spark. Simply, if you observe the hydrogen gas in a simple container, then this reaction will not occur. But whenever energy is supplied in too much high, at least electric spark, then these will be split out. And then what is the reason? The electron of hydrogen atom are excited to a high energy levels, and the high energy orbits to which electron migrate depend upon the amount of the energy absorbed by the electron. Similarly, ground state and the excited state has a high energy and the ground state has a low energy. And energy levels, these arrows basically show the energy levels, where is the excited state and where is the low energy state. These excited electron basically unstable state, and that's why they come back to their original energy level when they lose the energy in the form of photons, which split out from the energies and they go back to their ground energy state, and which is basically low energy state. High energy state, excited state, low energy state, stable state. You can also say the ground energy and the ground state, yeah, low energy state. And the electron may come to their lowest, you can say that they come to back to their lowest energy state from the excited high energy state, and in this way they emit energy and they had absorbed. What is in this light? Hydrogen gas in the tube and the detector photographic plate. If you took the prism and radiate the energy high voltage arc, and the slit line spectrum of the hydrogen will show that 410 nanometer, 434 nanometer, 486 nanometer, and 656. These are basically line and the wavelength range of the line spectrum of the hydrogen from the prism. And how we obtained it? From the photographic plate in front of prism, and after absorbing the radiating energy, hydrogen gas in the tube at high voltage split up, and line spectrum, this line spectrum will be formed at the different wavelength. Wave number of spectral lines. Different spectral series are produced depending upon the excited and the ground energy level of electron, and wave number of these spectral lines can be calculated. ये जो है वो basically बहुत क्वेश्चन है जो आपने एफएससी में भी जो है वो कवर की हुई है 1.09 कैलकुलेटेड फॉर्म है, और एन जो है उनके एनर्जी लेवल्स हैं. एनर्जी लेवल्स बेसिकली आपको स्प्रेड करके बताते हैं कि हाउ मच फ्रॉम एनर्जी लेवल इट्स फ्रॉम हायर एनर्जी लेवल to a lower energy level. When number of these spectral lines you want to calculate from the Bohr equation, you only put up the energy level in this equation, and you can calculate the energy of these lines, that how much energy they have from this equation. Wave number. This is the spectra. The red wavelength has 657, blue green has 486, violet has 434 nanometer, and electrons excited from 1, 2, 3, 4, 5, 6 are basically energy levels, and from higher energy level to lower energy level, they emit the radiations, and these wavelength lights will be shown in the spectrum: red, blue, green, and the violet at the different wavelengths. And energy level, you can show that from 4 to 2 energy level, from second to 1 energy level, red light will be emitted. Similarly, fifth to first, violet light will be emitted, and from blue light from the fourth to second energy level. And different lights will be formed when 6 to 2, 4 to 3, and 2 to 1. It means that it depends upon from which shell it is basically de-excited at the ground state. Here is the Lyman series, spectral lines in the Lyman series, and which explain the consider that electron falls back to the n equal to 1, and 1 mean first energy level, as you can see in the previous slide, and from first is nearest to the nucleus. This is the first level, and higher levels basically n1, n2, and n3. Here if I put up the first level to second level and n2 greater than 2, 3, 4, then you can calculate every energy level, because they are multiple of integral multiple of n, and basically distance between the first to 3 is basically same as compared to the shells. They have the equal distance. That's why if you write down they go back from 6 to first energy level, you will be only put up the 6 in the n2, and you will calculate the energy. What is the Lyman series? First line n1 basically 1, n2 basically 2, and similarly wavelength will be 82.26, and n7 है, and n infinity पे भी आप calculate कर सकते हो. From n1 all are coming back to their ground state from n1. That's why I wrote down n equal to 1, and n2 2, 3, 4, 5, and 6, and so infinity. ठीक, तो यहाँ से आप जो है वो फर्स्ट लाइन, सेकेंड लाइन, थर्ड लाइन, एंड लिमिटिंग लाइन जो है वो कैलकुलेट कर सकते हैं आफ्टर पुटिंग अप द values to ultraviolet regions for the Lyman series. What is the Balmer series? In this series, the electron falls back to n2. As the Lyman series n1 and Balmer series has n2, and you can put up n1 2 square and n2 from any number mean infinity, then you can calculate the Balmer series. Here is the values of the Balmer series. For the first Balmer series 15.2, similarly if from fourth level 20.5, and fifth level 23.05, and there is basically alpha, beta, and gamma hydrogen lines, which are basically from the high energy level to a low energy level. This is the Paston series. In this series, electron fall from n3. There is no need to be explained, as I explained before, that only you will put up 3. And for the first infrared region of the Paston series will be 5.3. And similarly, if from 7 and infinity, it will be 12.18 for the infinity. Limiting line is को हम बोलते हैं. And for the second line, which is from the third one, it will be the fifth one, यानी third, fifth से third level की तरफ. You can also calculate it back series. In the series electron from n4, similarly 1.09 will be the same, only n1 will be 4, and you can calculate this series. For series back to the n equal to 5, you only change the number by 1, and the next series will be obtained. For the first energy level in this series, frequency will be 1.3 into 10 raised by 5, and limiting number n infinity 4.3 into 10 raised by 5. And here energy level, lowest energy level is n5, and furthermore the higher energy level from the 5 will be their first one. And this is basically is the graphical representation of n1, n2, n3, n4, n6, and infinity. Energy is 1312 kilojoule, 328 kilojoule, 146 kilojoule, and 82. All the series and different Lyman, Palmer, Parston, Beck, and Puffman 5 series and their energy levels from high energy level to a low energy level. The infinity has 0 kilojoule, and from Lyman is 1312, highest energy level, lowest. And thank you very much. Have you any question? Question is indicate about the Lyman series, explain the Lyman series, and why absorption spectra are produced.